Hello. This tutorial should help you complete your homework over Constant Velocity Worksheet 8. By now, you should be able to sketch the velocity versus time graph if you are given a position versus time graph. On this red line right here, we can see that it goes up 3 meters in over 2 seconds for a velocity of 1.5. And we've got a velocity of 1.5 for 2 seconds on our velocity versus time graph. Slope is velocity. For our green line, it goes down 2 meters and over 4 seconds, so -2 over 4 for a -0.5 meters per second. So this slope is a -5 meters per second velocity for 4 seconds. And then finally, our other option is a zero slope as a zero velocity, so we have a zero velocity for 3 seconds. What we're going to look at now is if we take one of these at a time, this position versus time graph and this velocity graph, what does this velocity graph tell us? We know that the slope is 3 meters in 2 seconds, so that's 1.5 meters per second. But we want to take a look at is this area underneath our velocity versus time graph. If I draw this down to 2 seconds, this graph says that I'm going 1.5 meters per second for 2 seconds. Now for some of you it'll be obvious, you can just do that in your head, but if you're doing 1.5 meters per second for 2 seconds, if I plug in the 1.5 meters for my velocity and 2 seconds for my time, we'll see that your displacement is going to be 3 meters. The other thing that I want you to see is I'll go ahead and make a little box to represent this, is that this area of this region right in here, this box is 1.5 meters per second tall and it is 2 seconds wide. The area of this box is the same thing as the displacement. And that is what you're going to need to learn for Worksheet 8, is the fact that the area is equal to the displacement. This has an area of 6 meters, 1.5 meters per second, times 2 seconds, and it's got a displacement of 1.5 meters per second times 2 seconds. So the area underneath this graph is the same thing as displacement. This is a big idea. Once again, if we look at the green graph just by itself, we know this has got a velocity of -0.5, and if we're going -0.5 for 4 seconds, then -0.5 times 4 would give us a -2 meters. And if we start at 2 meters and we end up at 0 meters, that means we went to the left 2 meters. So this area, I'll put another box in here. We'll use a green box with a green area. Since this box is underneath the axis, that means this is going to be a negative displacement, and it just means it's to the left. So once again, we see that area is equal to displacement. The area underneath, the area between the curve and the axis, that area is equal to displacement. So what happens if we have a multi-stage graph? This slope is 1, it's up 1 over 1, so I have a velocity of 1. This slope is 0, so I have a velocity of 0. This slope is -2, so I've got a velocity of -2. And another slope is 0, another velocity of 0. So if we want to look at the areas of this graph, once again we can look at this area right here. That's going to be a positive area, will be a positive displacement. And then this area underneath here will be a negative displacement. So we can see that for this one, since it's 1 meter per second for 1 meter, we're going to travel 1 meter. And from 0 to 1 is 1 meter. This is still 1 second, and this is negative 2 meters per second. So this is going to be a displacement of negative 2 meters. And from 1 all the way down here is a displacement of negative 2 meters. On the next slide, this is one of the problems from worksheet 8. We can see we have a velocity of 2 meters per second. This is 1, 2, 3, 4. So this is 3 seconds right here. So for this one, if I was drawing the position versus time graph, if we started at the origin, so with a velocity of 2 meters per second for 3 seconds, when I draw the position versus time graph, it's got a 0 velocity for 1 second, so it's going to stay in the same position. But this time, if I were to look at this area of this box right here, this would be 2 tall and 3 wide. That would be 6 meters. So I'm going to draw a straight line from here up to where I think 6 meters would be. And this is going to happen at 4 seconds. Because I go from 0 meters up here to where 6 meters is, from 1 second to 4 seconds. And then for these next 2 seconds, I've got a 0 velocity. So I'm not going to go anywhere else. So I'm just going to have a nice horizontal. I'm going to stay at this 6 meter mark. And then right here I've got a negative 1 velocity. And this is for 2 seconds. So if I were to draw, I can go ahead and draw those rectangles in there. If I were to draw those rectangles, this rectangle, that's the one that has an area of 6. And then this rectangle would have an area of negative 1 for 2 seconds. Let's have a displacement of negative 2. So I'm going to go from 6 meters down to 4 meters. So when I draw the next part of my line, I'm going to keep drawing this from 6. Sorry, that's the wrong color. That's okay. From 6 down to 4 meters in 2 seconds. And then for the last 2 seconds, we're going to go ahead and have a 0 velocity. So I'm actually going to scoot this over a little bit to make sure it comes over here. It's kind of hard to tell without a grid. I guess it should be over here. The idea is that this comes from 6 meters down to 4 meters, and then the last section of the line is just going to be a horizontal line. Excuse me. Last section of the line will be a horizontal line. And sorry, different color green. That different color green don't mean anything. It's just the way colors I picked. So a 0 velocity means my position stays constant. This area of 6 means I go from 0 to 6 meters. This area of negative 2, it's below the axis with a negative velocity, means I come back from 6 meters down to 4 meters. And the other way you can look at it is if you go backwards, 0 slope is 0 velocity. This slope up 6 over 3 would give me a velocity of 2. This slope of 0 would give me a velocity of 0. This slope of negative 2 would, or this slope of negative 1 would give me a velocity of negative 1. You're just working backwards from this graph to get your initial position versus time graph. And then once again, the second problem on worksheet 8, it says the numbers and the velocity versus time graph represents the area. So once again, that area is going to be displacement. So if I were going to draw the position versus time graph for this, I would go ahead. If I've got a 0 velocity, I'm not going to change my position. The problem says I start at the origin, so that's why I started at 0. If this is 24 and it lasts 2 seconds, that means this velocity is 12. So my slope has to be 12, and I've got to end up up here at 24, right about here. This is the 2 seconds that it takes, and then this is 25, so just a little bit below there. And then right after that, I've got a negative 18 displacement. So I'm going to come back down in 2 seconds from here. I'm going to come over 2 more seconds to 5. And if I went forward 24 and I come backwards 18, that's going to put me right at 6 meters. And then I'm going to stand still for 1 second, so I'll stay there at 6 meters. Now I'm going to go forward 27. From 6 meters forward 27 is going to put me up here at 32, and that takes 3 seconds. And the last little chunk is a 0. Okay, so this area means that I go forward 24 meters. This area, since it's below the axis, means I go negative 18 meters. I come back down 18 meters. And then this area being a pot of 27 means I increase my displacement by 27 meters. This is my displacement, my position on this axis, and this is my time. Hopefully this video will help you on homework number 8. Have a great day, and I will see you in class on Tuesday.